Hello, hello, hello. How are you? Welcome, everybody. It is Monday. It is Monday of the last week of World Quant. Can you guys believe it? Here we are. We've done seven whole complete weeks of this course, and now we're on the last week. Welcome, everyone. Congratulations for making it this far. A big pat on the back to you for doing this. I am so amazed. I'm so impressed. And it's so exciting to see so many faces, familiar faces here in the chat. I see Putha, Charles, Aman is here, Apurva, Anis is here back. Welcome, good to see you again. Karishma, Andrea, Bruna, Apurva, Ali, Saud. This is fantastic. Chen is here. Chen, I feel like I haven't seen you in forever. Rashid is here. Gebernesi is here. Yahia. Wonderful, wonderful. It's good to see everyone again. Good to see you all. I hope you all had a good weekend, a restful weekend, or a productive weekend, or maybe both. And I am looking forward to one more week of doing answering your data science questions. I see Tam is here from Vietnam. Welcome, Tam. So good to see you. Let's open up the chat window here so that people can see. There we go. Okay, beautiful. So I have a question for you guys. What would you like to look at for today's office hours? I see Abhishek is here. Welcome, Abhishek. Bishoy is also here. Mika is joining us today. And Aman definitely wants to see the DW mini project. We are very close. People are raring to see DW. Chinmay is also here. I'm sure Chinmay also wants to see DW. All right, well, I see a lot of votes for the DW mini project, so I'm just going to dive right in. After my sip of coffee, of course. Okay, let's get started. I'm going to go to my home folder and I'll click on data course and then data wrangling and then mini projects and DW mini project. And let's see here. I'm going to just clear the kernel. Actually, it doesn't really matter if I clear the kernel. Kingsley is saying it wouldn't be data science without the coffee. Very important. Very important to have coffee as a data scientist. Or tea. Maybe a nice mate would be good. All right. So here we are. We're going to scroll all the way down to the question that we're interested in, which happens to be question 6. The other thing that I'm going to do is I'm going to go cell, run all above. So that way I know my notebook is ready to go. And I'm not sure why this popped up, but I'll just remove that there. Okay, great. So we're at question 6. Is that right, guys? Okay, question 6. So what do we want to do in question 6? We want to see if the question we want to answer is, does an individual doctor's office, do their prescription costs originate from routine care or from a reliance on rarely prescribed medical treatments, right? And the idea is that commonplace medical treatments, they have a lower cost because they're performed more often, so there's economy of scale. And so that means that sometimes there are practices that just do rare medicines, maybe because they're needed or maybe because they are, trying to bump up their own profits. Vincent wants to know if it's possible for the grader to have it wrong. I suppose that anything is possible, but it is much more likely that there's something wrong with your answer rather than the grader. Okay, so the first thing that we need to do is, well, we want to identify practices whose costs disproportionately originate from rarely prescribed items. And that means that the first thing we need to do is we need to identify which BNF codes are rare. All right. So the first thing that we need to do is we need to find prescription rates, all of them, those p-values for all of the prescription rates, which means that I need to look at scripts, BNF code, and I need to find the number of unique prescriptions. So how can I find the number of unique prescriptions available in the BNF code column? Okay, Yaya and Nicholas are giving me some great ideas. I can use the N unique method, and we can see that there are 1,975. So we could say that our default here, our default P is going to be 1 divided by 1975, or this, 0.0005. So I'm going to save that as P. And then the next thing I need to find is the rate of prescriptions, the rate of prescriptions. So how can I find the rates for each prescription, the amount that it is prescribed? Now I'm not interested in the practices yet, but engineer Hafiz has a really good idea, which is that I can, if I want the rates, it's going to be the count divided by the total. So how can I write that in Python language? How can I get the count for each BNF code? What do you guys think? I'll make this a little bit bigger, the text a little bit bigger, just in case here. There we go. So Nicola says I can start with the value counts. So I could go scripts dot BNF code, and then I could do value counts. Let's see what that looks like. Okay, well here I have the value counts, and how do I get the total? Where can I get this total number? Because I need to divide this by something. So one thing I could do is Andrea has this idea of doing length of scripts, and that'll give me the number that I need. But the question is, what happens if I divide this? Actually, that works. I am a little surprised. Yeah, I could do length of scripts. That would definitely work. Yep, that'll definitely work. Beautiful. Or I could have done shape 0, as Saud is recommending. Also possible. These are all good options. All right. Now, what I need to do is I need to find the rare codes. So the rare codes. So I need to find the rare codes, which means I'm going into rates, right? This series that I just made, I need the rates series. And then how can I get the ones where it's less than this number, 0.01 times p, or excuse me, 0.1 times p. So I need all of the BNF codes where the value associated with that code is less than 0.1 times p. What do you guys think? Whoops, I almost dropped my coffee. That would have been very unfortunate. Jay's just joined us. Welcome, Jay. Glad you're here. We're on question 6 of the mini project. People are really excited. Now, Rashid has a great idea, is that I could use a filter and I could start with, and I'll call this a mask, okay? I'll call this a mask, and I'll say my mask is rates less than zero point 0.1 times p. Oh wait, I need to spell rates correctly. And let's just look here also at 0.1 times p. This is our cutoff, this really small number. And so now I've created a mask. And if we look at my mask, we can see that it's a series. And if we look at the head of the mask, we can see that it's this Boolean array where the index labels are the BNF codes, so the codes of the various medicines. And then the values are true or false, depending on whether this original rate that we had here, this prescription rate, was less than 0.1 times P. So now that I have my mask, what I can do is I can go give me rates, but only the rates that fit the mask. And let's look at that head there. Here we can see I have all my codes. Now, if I want to get just the index values, because I'm only interested in the index values, how can I get those? I'm loving all these answers that you guys are giving me. Thank you, Suraj, Hafiz, Saud. Brian, glad to see you could make it. Happy to see you here. And the question is, how can I just get only the index labels from here? Because I only want the codes. I don't need the values. I just need to know. Now, Shaheen says I can reset the index. Let's try that. That actually returns a data frame, and I have the index here. But Rashid is also right. I can just do dot index, which is an attribute. And so here's a list. It's 844 long just by typing in index. So I can save this as rare codes. And here's a question for you guys. If I look at the length of rare codes, I can see that it's 844 long. Do you think that there are any repeats in here? Like codes that are repeated? How can I find out? One thing I could do is I could try the unique. Let's see if that works here. Unique. Actually, it looks like it's 844. It looks like it's the same. Now remember that I don't want n unique because that would give me the number of unique values, right? That would turn, if I did n unique, this would give me a single number. But if I do unique, it'll return a list, which I can actually use. So I actually just want the unique codes themselves. I don't want to know how many of them are unique. But the good news is that it turns out to be 844, so I'm good to go. These are all unique codes. So let's just look at this rare codes. Let's just see what this looks like. Whoops. Okay, great. Beautiful. Now, Jay has a question. How can we get the index value according to the values for the case of rates mask? That's a great question. So what happens here is I have my mask, and if I want to get the index values, I just need to type in .index. And the index is an attribute of this series, so I can just get it there, and then I can put unique on the end of it, and I'll get all the unique values. Other questions? Other questions about question 6 up to now? Now, Ekimini has a great question. They want to know what a mask is. And let's take a look. If I look at this mask, I can see that I have this is a series, right? And if I look at the series, I can see that I have the labels as the index labels that correspond with the different BNF codes, the different medicine codes. And then the values in this series are a bunch of true and falses. In this case, we only see false, just because that's how it happens to be. And once I have this Boolean series, what I can do is I can input it here inside brackets, and it'll filter that series, and it will give me all the rows in the series where the mask is true. And I'm seeing a lot of great answers about what a mask is. Thank you, guys. And so, for example, if I look at mask and I see the length, I can see the mask is 1,975. But after I put it through this, after I use that mask to filter, I can see that rare codes is only 844. So we are filtering out about half of the rows in this data frame, excuse me, in this series, and we're signaling that they are rare. They're rarely used. So I have my rare codes, and now I'm going to use that information to create a new column in my scripts data frame. So I'll look at scripts just so we can remember what it looks like. I have characteristics about the drugs, I have their code, I have their name, I have whether they're an opioid or not. And I want to add a new column that's going to be ones and zeros. And the new column should basically be, if it is a rare code, it should be a 1, and if it's not a rare code, it should be a 0. I see Miriam has joined us. Welcome, Miriam. So what we're trying to do here is we're trying to create a new column for our data frame where if the BNF code here is rare, we make it a 1 in our rare column, and if it's not rare, we make it a 0. So how can I do that? Bruna has an idea. I can use is in. That's a good way to do it. Sahin has the idea of using a list comprehension. I love this. I love what you guys are doing. This is amazing. Let's try Bruna's idea. So I'm going to go to scripts, BNF code. And in this case, I don't need a list comprehension. I can just use is in. So what this is saying is it's saying look at every row in the BNF code column, and if the value you get is in rare codes, then make it true, and if not, make it false. So let's just see what this looks like. Here you can see that I have these false, false, false. The other thing that I can do is I can go as type int, and now I have them as ones and zeros. So if I look at scripts.rare, and then I look at the sum, I can see that out of the 19, or out of that giant data frame, what is that? Out of the rare, let's see here, count, out of the 900,000 or so prescriptions, I can see that around 11,000 of them are rare. Okay, we're doing really good. We're making good progress. Questions, questions, questions. What do you guys think? Is there any part of this that you feel is not clear that we could make more clear? I see Dalton is joining us. Hi, Dalton. Good to see you. Questions, questions. Tiger wants to know how I calculated the probability. The probability we calculated up here is we just took the number of unique values and then had a 1 over it. So the probability is basically 1 out of all the unique drugs that are possible to be prescribed. So it's 1 over n. Shaheen wants to know if this is the last week. It is the last week. Oh my gosh, last week of Unit 1. Can you believe it? Are you guys ready for Unit 2? Has everyone applied to Unit 2? I hope so. Good, good. I'm glad. I'm glad. All right, I'm glad to see that people are applying to Unit 2. Excellent. That's great. That's good. Well, if you guys are in Unit 2, then I'll be there. It's going to be 8 more weeks of me in 2020. Looking at machine learning. Can't wait. All right. So for each practice, we now need to calculate. Oh, let's see here. Some people want to know where you apply for Unit 2. Does anyone have the link that they can share? Let me see if I can find the link before we move on, because I want to make sure everyone has it. Give me 1 second. One moment, please. Okay, here is the link. There we go. WQU-apply. All right, beautiful. So what I'm now going to do is we now need for each practice to calculate the proportion of costs that originate from prescription of rare treatments. And if we scroll up and we look back at our, actually, I think I already deleted that cell. If I look at the scripts.head, we're going to be using this, the ACT cost. So the first thing that we need to do is we need to, let's see here, for each practice, we need to calculate the proportion of costs that originate from rare treatments. So how can we do that? What is sort of mathematically, what is it that we need to calculate here? So the first thing is I need the, right. So what I need is I need the total cost per practice, and I need the rare script cost per practice. So we're looking at the ACT cost. All right. So the first, let's start with our denominator. How do I get the total ACT cost per practice? I know I have to start with scripts, but how do I get the total ACT cost for each practice, each doctor's office? Charles has the idea of group by practice, so I'll do group by practice. So I'll do group by practice, and in fact, I'm just going to steal Nicholas's code there. One Nicholas is going to save the other Nicholas's code. and I'll do the sum. Let's just see what that looks like. All right, beautiful. So here we have the total ACT cost by practice. All right, excellent. Thank you, Nicholas, for that idea. And that is our denominator. The question is, how do we do our numerator now? Now I need this information, but I need it only for the rare scripts, the rare scripts. So I need this same information. I'm even going to copy and paste the same line, but this time I need to filter it. I need to filter it by only the rare scripts. How can I do that? I love it, you guys. I love it. You guys are really on this. So what I'm going to do is I'm going to say scripts rare. Actually, I wonder if this will work. No, that won't work. Hold on. Key is missing. Let me see here. When I get a type error, oh, I know why. I need to do it like this. There we go. So there are a couple ways that I can do this. I can filter it for one. The other thing that I can do is I can actually revise the way that I made this originally. I made this rare column. I could instead of making it an integer column, I could just turn it back into a true false Boolean array so that it's true and false. And then I don't even need my little equals 1. I can just do scripts and then filter it by scripts rare, so whichever one is true, and then I'll group by practice, and then I'll get the account cost sum. Let's see what that looks like. Looks pretty good. And actually what I'm going to do is I'm going to take all of this and I'm going to wrap it in parentheses. And I'm also just going to do fill NA 0 so that everything is full, even these ones here at the bottom. And I can save this then as my rare cost prop. And I'm one step closer. So now we have for each practice the proportion of costs that originate from prescription of rare treatments. And it looks something like this. So we can see that in the first practice, 1% of their costs come from rare treatments. We can see in this one at the bottom here that it's even less than that. It's 0.007. You guys have really got this. All right, so now that we have that information, we want to calculate a z-score for each practice based on this proportion. And it says, first take the difference of rare cost prop and the proportion of costs originating from rare treatments across all practices. So on the one hand, it says that I need my rare cost prop, and I need the difference. I'm just going to put this on a new line for just 1 second here. Next, I need the proportion of costs originating from rare treatments across all of the practices. The number, so I need to do this calculation again, except not per practice, but overall. So I need to do scripts, account cost, sum, and that'll be my denominator. And then I need to do scripts again, except I need to filter it first. By rare. So in fact, why don't we take all of this and let's wrap it in parentheses so it's easier to read. And then let's start making some line breaks here. Actually, I think I'll put this back here, and then I'll put this here. I'll maybe indent it 1. So here we have the relative rare cost. So I have the rare cost proportion, and it'll be the difference between that and this other proportion which we have created across all of the practices. So if I look at relative rare cost prop, I basically get how far it is away from the overall, it deviates from the norm. So this is my z-score, my z-score. Okay, questions, questions. Questions, questions, or should I keep going? Anissa's got it, that's great. All right, so then the next thing that I need to do is I need to get the standard errors, which means I just need to take the standard deviation of that difference. That seems pretty straightforward. I'll take relative rare costs proportions, and I'll just do STD, and that'll give me the standard error. Let's see what that is, or the standard errors, I should say. I think technically this should be standard error. And now I need to compute the z-scores. So how can I calculate the z-scores? I have my relative rare cost proportion. And now I just need to find out how many standard errors they are away from the mean. So I need this as a proportion of standard errors. How can I do that? Suraj says I can just divide by the standard error. Let's try it out. So I will divide by my standard error, and I'll wrap this here in parentheses. And now we're getting something a little bit more interesting here. These are great ideas, guys. Thank you. So, all right, I have the z-scores. I have the practice. Now I need the name here. I need the name. Oh, I also need the top 100 z-scores. So I need to add the name of the thing here. How can I do the name? Andrea says I can do some kind of merge, and that's absolutely right. In fact, if I look up unique practices, I actually have this information. Oh, wait, here. Where is my unique practices? I thought we did this before. I have ellipses. Where are my unique practices? Excuse me, everyone. Sorry about that. Okay. So I need the unique practices here. I could have sworn that we already created a list of unique practices, right? Hold on. Let me see if I can just find this. Here we go. We have unique practices here. Yeah, unique practices. Okay. Unique practices. We have this here, so I'm going to scroll down. I thought we did. I thought we did. So I'll look at unique practices. Here it is. Oh, no, wait, this is unique practices. This is the postal code. Curses. I don't need the postal code. Let's go and find it again here. What I'm going to do is I'm going to take this code again. I'm going to copy and paste it. So I'm going to scroll down to where we were before. And let's see here. Here's where we were. I'm going to list of unique practices. And instead of sorting values by postcode, I'm going to sort it by practice name. Group by code first, reset index, and then it'll be code and practice name. There we go. Oh, I got a key error. Hold on. Oh, practice name is not in that list. Okay, hold on. I know I have all this information here somewhere. So if I go to scripts, I have the practice name. No, it's not here. Hold on. If I go to practices, oh, it's just name. So I will take the code that I had before and I'll do sort values by name. There we go. And now what can I do to get these two together? I could merge, I could do concat. I love all these ideas. Keep in mind, though, that we need to make sure that we're aligning our codes here. And so we need to make sure the indexes match up if we're going to do concat. So I would actually have to do unique practices, set index code in place equals true. And then look at unique practices head. There we go. And from there, I could do something like PD concat. And I could say, I want you to concat unique practices and this data frame we just created. And the axis would be 1. Oh, it's unhappy with my syntax for some reason. This is invalid syntax? Oh, I know why. I'm missing a... Nope, that's not it. Interesting. Well, I can just save this then. Let's call this rare scores. And then I'll do unique practices, PD concat, and I'll do unique practices and rare scores. Axis equals 1. And here we actually have what we're looking for. We have our rare scripts. We have a lot of NAs. That's okay. What we'll want to do is we'll want to sort values by ACT cost. And we'll do ascending equals false. Or no, wait, ascending equals true. What do you guys think? Oh, I have to remove head from rare scores. That's why it's weird. You're right. Thank you. There we go. And I'll make this false. There we go. And I need the first 100 of them, right? So I'll do head 100. I will explain, Jay wants me to explain how axes work. I think we're so close to finishing this. Let's see if we can finish it, and then we can go back and answer that question. So I'm going to call this my rare scores. So if I look at rare scores dot head, here are my scores. And now I need to turn this into a list of tuples. So how do I turn this into a list of tuples, guys? I have this list of tuples. How do I turn it into... I can use iter tuples. Absolutely, thank you. So rare scores, iter tuples, and I'm also going to have name equals none. And now I'll just look at rare scripts again. I'll just look at the first 3 values or so. Whoops. Oh, wait, I need to turn this into a list. There we go. And then I'll do rare scripts. Beautiful. Okay. And let's see if this works. Fingers crossed, guys. Last problem of last mini project. This is very exciting. 3, 2, 1, blast off. Hey, we did it. Do 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 do. We did it, guys. We finished. I feel like balloons should fall down from the ceiling. Absolutely. Wow. Good work, guys. So exciting. We did it. Okay. Well, I'd love to review the answers, but unfortunately, we are out of time. So here's what we'll do. Tomorrow, we'll do a review of number 6, just for people who have questions. And then after that, we'll spend the rest of the week just answering any questions you guys have, including how can I download all of my notebooks so that I can continue learning after the course is ended. So congratulations to everyone for finishing question 6. Thank you so much for your help. And I will see you all tomorrow. Bye bye. Take care and happy, happy, happy data science. Bye bye, everyone.